Okay, here's topic 7 test. As soon as it starts recording. Okay, topic 7 test, version 2, the answer key. For this function right here, if you're given an exponential function, I highly recommend sketching it to find the y-intercept and asymptote. I'll do this one from scratch. We know the parent goes through right there at 0, 1. So what else has happened to this function? Well, let's see. A is multiplied by 4. So instead of 1, it's going to go up to 4. There's 4. But then the whole function is moved up 2. So that's why the y-intercept is at 6. And remember, the whole function being moved up 2 with the k, it moves this horizontal asymptote up to the y equals 2 line. Okay, you guys really need to look into this on topic 5, more about graphing exponential functions. Okay, if you're section 5-1, 5-2, I think, are the places to look for that. Or you can come ask me for help, obviously. Same thing with this one. The midline of a sine or cosine is always going to be k. The equation, the midline is always k, and it's always a y equals. That's just straight recall right there. For this one, this graph I changed around. This is a cotangent because it's always decreasing. But I changed its period to be 2 pi. So period for cotangent is pi over b, not 2 pi over b. For cotangent and tangent is just 1 pi. Set that equal to 2 pi and solve, and we find out the b coefficient is 1/2. That's how we get that 1/2. And the amplitude right there at the change of inflection, if that's 5, that's 1. So that's why we have a 1 out there for amplitude. Okay, this one is h and k, interpreting which one. This one is right 8 units because h lies. This one is the same thing. Right as a single logarithm, I still had students giving me 15 log 2x, and I wanted to pull my hair out. You've got to use the power property to move the exponents inside, and then the product property to multiply these two things together. That's how you condense logarithms. To see which point is another point that's on there, you take the 2 points they're given and see what happens. Okay, from 12 to 28, I multiply by 4. Okay, so do that same thing from 2 up to 3 and divide by 4 to go back to 0. Which of these coordinates is on the graph? It's that one right there. I think I might have made a mistake in grading students. That's why I said oops there. So if you have a change in that, if I need to fix that, come talk to me off camera. Hey, if you can't memorize the unit source, you're going to get a 0 on the finals for this semester. And here again, here's the Talisa shadow problem. There it is. Angle with the ground is on the ground. There's the shadow. Use tangent to find x. Done. Turn the page. This was the same graph for both versions. I just changed the date range here. I changed this one to make this one just that interval. It's just that interval right there. And it's negative, I don't know, about $26,000 per year. That part of the context is important. So negative $26,000 per year. Is this a good indicator in that time range for what happened to the company? Yes, it is. Here again is the changing the base. This goes down to 2 to the 5th. This goes down to 2 to the 6th, and correctly distribute. All right. This one was the probability that a random student chosen likes rap is a 10th grader. Okay. So that means the probability that they're 10th grader given that they like rap. So we go to given that they like rap, and it's 10 out of 15. Oh, I'm sorry. Did I do that? 10 out of 6. Is that a 16? Yes. Yeah. Sheesh, that's a 16. So that's how you get that one. This was just finding a z-score, just remembering that formula, data point minus mean over standard deviation. You were given all of that information, and just figure out the number. I did not ask you about percent to the left or right under the standard normal curve. Like you will see that question on one of the other versions. You need to be familiar with this concept, the percent of the distribution to the left or to the right. Last one for this video. The LCD is 24x. I know I taught you guys to take this very, very slowly. Let's see, you write the LCD. If you're just adding or subtracting, we're not solving. Okay? If we're just adding or subtracting, you write down each term's LCD. What did I do to 8 to get here? I multiplied it by 3x, so do the same thing to the numerator. Do the same thing for the other fractions, and then see what parts of the numerators can reduce down. Okay? That's it for that video.